Alright, this is the last video for Class 2 for Optim Calculus 3, and we just want to kind of start wrapping things up. There's this notion of level sets, and we talked about them for 3 dimensions, but what about the other dimensions? So we have, certainly from our previous knowledge, we know that if we have 2 dimensions, x and y, okay, we can plot a value x naught, and then we can look at a corresponding value on the y-axis, that is f of x naught, and so we'd have this point that is the intersection of those two things. Alright, and level, so if we think about level something here, right, I want to come back to this in a moment, but we can talk about level sets in 2 dimensions, but what are they? Based on our previous discussion, when we talk about level sets in 3 dimensions, we said, well, it's going to be, and I should also label the axes as x, y, and z. We have this idea that, okay, well, we progress from x naught and, x naught and, what's going on? Okay, x naught and y naught, and then up to a distance of c, okay, and that would be, or we can actually think of that as the point x naught, y naught, f of x, x naught, y naught. And so that's kind of a general point in 3 dimensions, but when we were talking about level sets, we said we were looking at all of these points where they were equal to this defined value of z, where it was f, where the height was fixed, right? And in this scenario, we said that the level sets we actually called level curves, because these curves lived in R2. Okay, so then we have this case in R2, what do we call the level sets, and what if we had a function, for instance, if we keep on going, w, that is a function of x, that is a function of x, y, and z. Well, that's actually a function in 4 dimensions, right? Well, then the level, helps to write correctly, the level sets for this function, which would be a mapping from R3 to R, okay, that means we're looking at all x, y, z values that are a constant value. Well, this is a function in 3 dimensions, right? And so if we want to graph something in 3 dimensions, what kind of figure do we get? We get a surface. So here, we're actually going to call the level sets, in this case, when we have 4 variables and it's a function mapping from 3 to 1, we're going to call these level surfaces. Okay. That's kind of fun. So 3 dimensions, we have level surfaces. 2 dimensions, we have level curves. Then we have that case with 1 dimension. What do we call that? To my knowledge, we don't actually have a good term for that other than level sets. Maybe a level point. I don't know. It's kind of weird to say, but you could say a level point because that would be a 1-dimensional object, or a level, yeah, a point. Level curves, that's 2 dimensions. Surfaces are 3 dimensions. And I'll also say for higher dimensions, if we have something like f of r n to r, for n is bigger than 3, we just call these level sets. Okay, level sets is just kind of the catch-all. Okay, so Hopefully this has been a good experience with videos, and I'm interested in feedback from all of you on the videos and what can be done to improve. Otherwise, that's all the videos for Class 1, or Class 2 rather, of UmpTIMT Calculus 3, Week 2.